Hi everyone, this is Sejal, your tutor from Bright Mind Tutors. Today, I'm gonna discuss with you the topic that is how to calculate the concentration of a solution in the moles per decimeter cube. So, what does this basically the term concentration it means to us, and what is solution and what are these units basically? So, solution that it is made up of two of the parts. It consists of the solute and we have the solvent in it. Like through an example, if you consider this is the beaker you are having, and then this 1 liter water you are having. This is your 1 liter water. Now in this you are adding the salt to it. Our salt is sodium chloride, which is NaCl. Right. Now sodium chloride that I have, is the small particles you have in this. Right. So you are unable to find that how many number of particles of this sodium chloride you have added into the water. Right. So since number of particles we cannot find it because it is your microscopic in the nature. So in terms of the moles we talk about, like this is the solute that you are adding. So solute and the water is the solvent over here. Now to tell us that how much amount of solute is present in the solvent, the term that we define, it is called as your concentration. Right. Now number we cannot talk about, so we talk in terms of the moles. So moles of the solute present in the given volume of the solution. Volume of the solution. This is called as the concentration term. Like this, the various units we have to define this concentration. This particular unit in which we define the moles of solute upon the volume of solution. This is taken in liters. This is called as the molarity. Okay, so the units are mole per liter, or you can call it mole per decimeter cube, because 1 liter is 1 decimeter cube only. Okay, so through a question, let's describe this. So this question we are having. The question, it says the student found that 25 centimeter cube of the sodium hydroxide solution. What is sodium hydroxide? RNaOH. Right, was neutralized. So now a new term you are encountering over here. It is neutralized by 15 centimeter cubes of 0.0480 moles per decimeter cube of ethane dioic acid solution. So what is basically ethane dioic acid? It has the formula which is your COOH, and here also it is COOH. So total it becomes C2O4 and the H2. So this is the ethane dioic acid. So what we are reacting is the base we are acting. NaOH is your base and ethane dioic acid is your acid. So this reaction between the acid and the base that you have, acid plus the base, it gives us the formation of the salt and the water. This is called as the neutralization reaction. Neutralization reaction. Okay, so this balanced reaction is, so it's completely written that it is completely neutralized, which means all the acid that we were having in the solution, it has completely reacted with your base. Okay, so now this is given that we are taking how much volume of the sodium hydroxide, that is 25 centimeter cubes. So volume of the NaOH is 25 centimeter cubes of it, is neutralized by the 15 centimeter cubes of ethane dioic acid. Right? This is what is given to us. So again, now I have the volume of the H2 C2O4. It is also given us, that is 15 centimeter cubes, and the number of the this concentration is given for us. Concentration of the acid H2C2O4. This is given, which is 0.0480 mole per decimeter cube. So this is the data which is given to us. We need to find, the equation is also given to us. Firstly check, is the reaction balanced? So you see here 2 over here hydrogen and 2 from here the hydrogen. Total 4 it is there, and in the H2O 4 of the hydrogens are being balanced. Next, carbon 2 it is given. Here also it is the carbon 2, oxygen 4 over here and 2 over here, total 6. So 4 from here and 2 in the water, 6 is balanced. Next 2 Na, so Na2 is also being balanced. So if this reaction given to us, it is balanced. If in some of the scenarios it's just the reaction name has been given and the components are given, firstly try to balance this. Okay, now it is balanced one. So we have to find the concentration of the sodium hydroxide in the solution, which is in the moles per decimeter cube. We have to find it. So this particular question we can solve it in 3 of these steps basically. So in the step number 1, you can see we have been given the volume of the acid and the concentration of it is also given. We can easily find the number of moles of it because we have seen that concentration, it is defined as number of the moles upon the volume of the solution, right? So from here we can see that number of moles, it will be equal to concentration into the volume of the solution, right? So here we have the concentration, it is 0.0480. Units are mole per decimeter cube and the volume it is, that is 15 centimeter cube. 15 centimeter cube. Now units here, if you see, we are having here the decimeter and here is the centimeter. So units you have to make to be the same over here, right? Now I know this, my 1 meter cube, it is equal to 1000 liters of it. 1 liter, it is equal to 1000 ml of it, and the 1 ml is equal to the 1 centimeter cube only. That means it is nothing but your 15 ml of it, right? And also 1 liter is your 1 decimeter cube only. Okay, so that means this ml you need to convert it into the liter or in the decimeter cube, you will be getting it, right? So now 15 centimeter cube, it is nothing but the 15 ml only, because 1 centimeter cube is 1 ml only, and 1 ml will be 10 to the power of minus of 3 liters of it, right? Or it is 15 into 10 to the power of minus of 3 decimeter cube of it, right? So this volume, it will be in the decimeter cube, will be this much. So our number of moles, it will become 0.0480 into 15 into the 10 to the power of minus of 3. This has the units of decimeter cube. Here the units, they were mole per decimeter cube of it. So per decimeter cube, this decimeter cube, it will get cancelled out. So we are getting the moles over here, right? Unit of the moles. So how many moles we are getting? That is gonna come to be the 0.0007 moles. So these are the number of the moles of the acid that we are finding. Okay, so step number 1, we calculated the moles of the acid. So if you solve up to here only, that is solving the first step, finding the moles of acid, this is gonna give you 1 mark for your question. Okay, basically this question is your of the 3 of the marks. So in 3 steps we are solving it. Up to here it is the first. Okay, now the second step, you have in the step number 2, you take the mole ratio. You take the mole ratio. So in the reaction you are seeing that 1 mole of the acid, it is reacting with the 2 moles of the NaOH. Right? You can see the stoichiometry. 1 acid I am taking and 2 NaOH I am taking. So the ratio is of the 1 is to the 2. Right? It is 1 is to the 2 ratio we are having. That means the moles of the NaOH that you are having, moles of NaOH, it will be 2 times of the moles of the acid. So 2 times 0.0007 it will become. That is gonna be 0.00144 moles of it. Okay. So the moles of base also you have found now. Okay. So if you find this, this is gonna give you another mark. So first from here, 1 from here you are gonna get. Okay, now in the next step, that is the step number 3, because our ultimate goal is to find the concentration of the base. concentration of the base. So now as we see that in the neutralization reaction, all the acid that we are having, it is completely reacting with the base. So that is why we were able to find the moles of the base from the moles of the acid, because equal amount of them they will be reacting. Okay. So now the concentration of the base I need to find. Concentration, it is moles of the base upon the volume of the base. Volume of the base. So moles we have found it, that is 0.0014144. These were the number of the moles, and the volume of the base, which is your NaOH, it is given that we were having 25 centimeter cubes of it. So it is 25 centimeter cube. So the units here you are seeing, we are getting mole per centimeter cube it is becoming. It is becoming mole per centimeter cube. So again the conversion we have to do. Centimeter cube you need to convert it into the decimeter cube of it. So that means, since again we know that 1 meter cube it is equal to the thousands of the liter. 1 liter it is equal to 1000 of the ml, and the 1 ml is nothing but the 1 centimeter cube only, or 1 liter is the 1 decimeter cube only. Okay, so now we have 25 centimeter cube of it. That means it is my 25 ml of it. Right, now this ml we can convert it into the liter. It is 25 into 10 to the power of minus of 3 liters of it, or it is 25 into 10 to the power of minus of 3 decimeter cube of it. Right, so now this value of the volume we can use so that we can get the concentration in the units of mole per decimeter cube. So that means it will be 0.00144 upon 25 into 10 to the power of minus of 3 moles per decimeter cube of it. Just solve this. The answer you will be getting 0.0576. The units will be mole per decimeter cube. So this is gonna be the final concentration of the base, which is your NaOH. Right? So this will give you, if you solve this will give you another mark, and you will be getting your complete marks till here. Okay, I hope the question it is clear. So how we have performed this? Firstly, you took the given data where they were given the moles of the, we were given the concentration of the acid and its volume was given. Using this, we found the volume for this moles of the acid firstly. Then we looked upon to the balanced reaction, taking the mole ratio. You are seeing 1 mole of the acid is reacting with the 2 moles of the base. Right? That is 1 ethane dioic acid is reacting with the 2 NaOH. So the moles ratio is 1:2. So that means number of moles of NaOH that you are using, it is 2 times that of the acid. So that is why you multiplied it with the 2 over here. You found the moles of the NaOH. Now to find the concentration, just the ratio of the moles to that of the volume. This gives you the final concentration, and remaining to it was the unit conversion. This for the volume, the unit conversion that you are having, this one it is important. Always remember this thing. Okay. So this was all about the conversion, that is how to find the concentration in the units of mole per decimeter cube of any solution. Okay. So thank you so much.